Section 3.2, multiple angle identities. So we're going to be learning the double angle identities and the half angle identities today. So for sine double angle identity, there's only one formula. The sine of the double angle of an angle theta can be found by just using the 2 times the sine of theta times the cosine of theta. For cosine double angle, there's actually 3 different formulas because the first formula can be modified by plugging in Pythagorean identities to find one of the other 2. So if you only want to memorize one of them, the top one would be the way to go, and then you can always use Pythagorean identities to find what you're missing and get it all plugged in correctly. And then here's our double angle identity for tangent. Let's go ahead and do this example. Suppose the point -3, 4 lies on the terminal side of theta with theta in standard position. Find cosine 2 theta and sine 2 theta. In what quadrant will the terminal side of 2 theta be located when it is plotted in standard position? All right, we'll deal with that last part in a bit. So let's start with just worrying about theta. I'm going to draw in my triangle here. So I have my point plotted on a little graph. And here's my triangle, and this is angle theta. Okay. And theta is in quadrant 2, so that's why this is a -3 and this is a +4. And if we would need the hypotenuse, it would be 5 because this is a 3, 4, 5 triangle. If you don't know that, you can use Pythagorean theorem to find the 5. All right, so let's go ahead and follow the second question, which is find cosine 2 theta. So cosine 2 theta, why do I always leave the s off when I'm writing cosine? So cosine 2 theta, we can use any of these formulas. We have the triangle, so we can find sine or cosine pretty easily. So if we just use the first one, I don't think it would hurt. Let's plug in whatever this cosine value would be for this triangle here. So cosine of theta is going to be adjacent over hypotenuse, so -3/5, but then it's squared. So that would make it positive regardless. So because it's second quadrant, it's negative, doesn't end up mattering because squaring it makes it positive. Then we have sine of this triangle here, so that would be +4/5. We're going to square that and we'll still have a positive. And then we'll subtract these 2 values. So this gives us 9/25. Oops, I don't know why I wrote 12 instead of 25. 9/25. Subtract 16/25 because it's a positive 16/25, but we're subtracting it. And I still can't write a 5 for whatever reason. And then 9 minus 16 would be -7/25. So you know how usually we have to stop and think, well, what quadrant is this going to be in? And will our answer be positive or negative? Well, this time, that should actually be the answer. It should be negative. So if cosine is negative, that should give us a clue. Doubling an angle in quadrant 2 is going to be an angle between 90 and 180. So if we double the angle 90, we get 180. And if we double the angle 180, we get 360. So it has to be somewhere. Doubling an angle that's in quadrant 2 has to be in either quadrant 3 or quadrant 4. Since this answer is negative, where is that angle going to be? Fourth quadrant cosine is positive. This answer is negative. What does that tell us about this angle? It's probably going to be a quadrant 3 angle. That means that theta itself had to have been less than 135 degrees. It had to have been, because if we add 135 plus 135, we get 270. And so anything smaller than 135 would keep it in the third quadrant. Which makes sense because this side 3 is shorter than this side 4, so that angle is less than a 45-degree angle into quadrant 2. So I went ahead and answered like the last question already, but we haven't done the middle question, sine 2 theta. Let's do that one. So sine of 2 theta is equal to 2 sine theta cosine theta. It's not a bad little formula to memorize. Sine theta we already know is 4/5. Cosine theta we already know is negative 3/5 because we used them when we found cosine, right? So we've got our triangle right there to find them from. Let's go ahead and multiply all this together. So we have a 2 times a 4, which is an 8, and then 8 times negative 3, which is negative 24, and then 5 times 5 is 25. So negative 24/25. So sine has a negative value also. Does that also agree that this is a quadrant 3 angle? Both of them are negative, so that makes sense that it's a quadrant 3 angle and not a quadrant 4 angle. There's lots of things that lead us to understand why that's quadrant 3 rather than quadrant 4.